symbol. What's the Lewis dot symbol for F, for example? Yes.
7 dots.
From where you got this 7 dots?
I memorize it.
No, from the periodic table. Yes, you need to memorize it, but put it in the periodic. Tell me it's from the periodic table. Look at the periodic table, and you have to know from where this symbol comes. And always keep the periodic table in front of you and discuss things based on the periodic table. For example, if we put another symbol which is AS, what's the dot symbol for AS? You have to go look at the periodic table and tell me.
5.
5. How do you put them? 1, 2, 3, and 4. And then where do you put the 5th?
Anywhere.
Anywhere, it doesn't matter. You want to put it here or there or anywhere, it's okay as long as you do it this way. Good. Last example, for example, SP, SB. Yes.
Five also.
Also 5. 1, 2, 3, 4, and 5, and so on and so forth. I hope you know how to do the Lewis dot symbol. Very, very important to start with in this chapter. All right. Then also, I told you that what's a covalent bond? What's a covalent bond? Covalent bond is sharing of this electron, like so. To make, if it's 2 electrons, it will be what? Single bond, and we'll draw it like this. If it's sharing of these electrons is done by 2 electrons and 2 electrons from the dot symbol, then we're going to have what's called double bond, like this. And are we recording the way? All right, and if it is 3 bonds, I mean 3. It could be, I mean, and then this will be shared by the 2 elements. In this case, what do we call this bond?
Triple.
First one.
Single.
Single bond. You have to say this, single bond. This one, oh, why did they?
Pair.
Double bond.
We call this one double bond. And this one,
Triple bond.
triple bond. Or this one and this one are called also what?
Multiple.
Multiple bond, more than one. All right, we see this in hydrogen, as we said. This is hydrogen, comes with hydrogen to make it like this or like this. It's the same thing, same way of drawing symbols. And in this case, we say this is a covalent bond, covalent bonding, which is sharing of electrons. So the definition of covalent bonding is sharing of electrons. You have to know this definitely. All right. Now, there is, for hydrogen, hydrogen would like to have only 2 electrons. Only 2 electrons around it, and it will be happy like this. Lewis found that there is something called octet rule. Write the name, octet rule. What's the meaning of octet? Octa, what's octa? Octa, what's the meaning of octa?
8.
8, exactly. When you say octet rule, what's the meaning of octet rule?
Eight rule.
Rule of 8, exactly. Octet rule. I want you to memorize the name octet rule, which is done by Lewis. So Lewis proposed the octet rule. What's the octet rule? Octet rule, Lewis says that for some reason, elements other than hydrogen and helium, elements of course, other than hydrogen and helium, would like to have 8 electrons around it. How? Okay, when fluorine, which has 7 electrons, interact with other fluorine to make it, to make the bond, and there will be, how many bonds is this one? 2 electrons. Single. And we can go this way or this way. Now, when you look at these 12 elements, the shared electrons counted for both of them. Now, how many electrons around this fluorine? Count them.
8.
8. And how many electrons around this fluorine?
8.
As I said, the shared electrons will count it for both of them. How many electrons around the other fluorine?
8 also.
8. Is this clear? All right. That's why when we have, what's the dot symbol for oxygen? 1, 2, 3, 4, and I will deliberately do it. I should not, this is not the Lewis symbol. The Lewis symbol is actually 1, 2, 3, 4, 5, and 6. All right? But if I have 2 oxygen, I will restructure the Lewis dot symbol. How many electrons around this oxygen?
6.
6. And how many around this oxygen?
6 also.
Also 6. So there is, how many electrons does it need to make it octet?
2 electrons.
2 electrons. So what is going to happen? It will share them like this. And this way, if they share both electrons, both of them will take the other electrons from the other one. How many electrons around this oxygen now?
8.
And this oxygen?
8.
Also 8. And it is satisfied the octet rule. Last example, nitrogen. How many electrons around the nitrogen? To start with Lewis dot. 1, 2, 3, 4, 5. All right. How many electrons does it need to make the octet rule?
3 electrons.
3 more. So what I'm going to do, I'll do nitrogen, and I'll put 3 electrons on this side, and 2 electrons in here, still 5. And the other nitrogen, I'll put 3 electrons in here, and 2 on this side, 5. And then I will bond these 2 electrons together like this. Now, how many electrons around this nitrogen?
8.
And this nitrogen also 8 electrons around. Clear? Good. Now, water. We have water. We know that oxygen has how many, what's the dot symbol for oxygen? How many electrons?
6.
1, 2, 3, 4, 5, and 6. All right? How many electrons does it need to make 8 electrons around it? 2 more. Okay? If we talk about water, then this electron can be shared. Now, how many electrons around the water, the oxygen? 7. If there is another hydrogen and they share these electrons, how many electrons now around the oxygen? There are 8 electrons around the oxygen. And how many electrons around hydrogen? How many around?
2.
2. Why is 2? Why is not 8? Hydrogen is?
Because the nearest noble gas is helium.
Yes,
And has electrons.
nothing except 2. Why? Because this is the symbol for helium. You can go this way or this way. But as we said, helium and hydrogen are special case. Helium and hydrogen are special case. Is this clear? Good. Then as a result, we're going to make a single bond, a multiple bond, which could be double bond or what?
Or triple.
Or triple bond. These are called multiple bond, all of them. Double bond or triple bond, which we just talked about a while ago. Okay, let's look at CO2. That's CO2 now. What's the octet rule? What's the octet for oxygen? What's the octet for carbon? 4. All right? Okay, now the other oxygen. Now, the oxygen, how many bonds, how many electrons does it need more?
2 more.
2 more, so it will bond with these 2 electrons from carbon. Now this oxygen is satisfied with 8. How about this oxygen?
Needed 2 more.
So again, it will make double bond like this, and it will make 8 electrons around it. Now, how many electrons around carbon?
The 8.
How many electrons around carbon?
8. 8
Oh,
electrons.
okay, don't forget this. Why? Because actually it is available in both sides. Look at this structure, and without, I'm not going to do any counting. Don't forget, the carbon has 4 electrons. I'll put them like this: 1, 2, 3, and 4. The other carbon is 4 electrons: 1, 2, 3, and 4. I'll make this share. Now, without the hydrogen, how many electrons around each carbon?
6.
6. And how many electrons does it need more?
2.
2 more. So 2 hydrogen will come like this. 2 hydrogen will come like this. Now, how many around each carbon?
8.
8. And how many around the hydrogen?
4.
2.
2.
Good. All right. And this is triple bond. Triple bond here. We saw that we did this many times. I'll do this one now. The carbon, how many electrons around it?
4.
4. 1, 2, 3, and 4. Okay, and the other carbon also has 4. 1, 2, 3, and 4. How many electrons does the carbon need? 4 more. Okay, share these 3. Now, how many electrons around each carbon?
7.
7. And then the other hydrogen will make 8. Like this. How easy? How easy is this?
Very easy.
Very easy. Good. Now, I want to say one thing before I go to the next slide. If we have hydrogen and hydrogen, we can draw them like this. But we can also draw it like this. It's the same thing. Okay. And I want to tell you now that the electrons are exactly in the middle between this hydrogen and this hydrogen. So if we have a line here, you'll find that the electrons are exactly in the middle between this hydrogen and this hydrogen. Is this clear? If we have oxygen with oxygen, oops. This is the Lewis structure of oxygen with oxygen. And again, I want to tell you now, is this the right Lewis structure for the oxygen? Is this the right?
Yes.
Yes. And how many? Does it apply the octet rule?
Yeah, yes.
Yeah.
Yes. Yes. And also, I want to tell you that the electrons are exactly in the middle between O and O. Is this clear? Exactly in the middle. So again, if I draw a line here, it will be exactly in the middle of the line between them.
Because they are from the same atom, from the same element.
Atom. I'll tell you why in a while. Okay. Same thing with nitrogen. Now, how many electrons around each nitrogen?
8.
8 and 8. Let's apply the octet rule. Yes. I want to tell you again that these two electrons are exactly, shared electrons are exactly in the middle between this nitrogen and this nitrogen. That's what will happen. Is this clear? Now, I want to tell you now that when we have electrons shared between the two different atoms, the same atoms, the electrons will be exactly in the middle. Exactly, the electrons will be in the middle between, in this case, nitrogen and nitrogen. But when we have C and O, then they will not be exactly in the middle. They will be going toward one of these two elements. Actually, we will find this is also, if we want to draw the octet rule, this is the octet rule for carbon. This is the octet rule for carbon, but we will find that the electrons here are closer to oxygen than to carbon. I will talk about this in a while. But in this case, how many bonds are there between the nitrogen and the nitrogen?
Triple bond.
Triple bond.
Yeah.
How about between oxygen and carbon in CO?
Triple
Also
bond.
triple bond.
Now, let me ask you another question. Which one you think will be a stronger bond? This bond or this bond? Which is stronger?
triple bond.
Stronger is definitely triple bond. How about longer?
Double bond
Double bond is longer. Why is that?
because it's weaker.
Because it's weaker bond, so it will be. So if I give you the two numbers and tell you, for example, let's say that we have 121. This is the bond length. 121 and PM P. What's PM? What's PM?
Picometer.
Pico.
Picometer.
What's picometer? You have to memorize this. Don't forget it. You will need it always. 10 to the power minus 12 meter. Okay, if I give you these two numbers, and this is for CO double bond and CO triple bond, which one is for CO triple bond?
The first one, 121.
131? What is it? There's no 131.
For the double, I mean.
121 is for what? For which bond?
A double.
Double bond, exactly. And the 113?
Triple bond.
Triple.
These values were actually calculated, and we have this table. Don't memorize any number. Don't memorize numbers. But you should be able to compare between things. As we said, if I have, which one you think of these three will be the shortest bond? Number
Triple.
one or
Triple.
number three?
Number
Which
three.
one is shortest? Definitely number three. Which one will be the longest?
Single
Number
bond.
one.
Single one. Which one will be the strongest bond?
Number three.
Also, strongest among these three is three. Which one is the weakest?
Number one. A single one.
Good. All right. Good. Now, this table show you the relation between ionic and covalent bond. What's the difference between ionic bond and covalent bond? What's ionic bond?
So, yeah, one non-metal and one metal.
And what will happen? What will happen?
One
The
lose electron, the second
One loss and one gain.
electron.
lost from the metal, the electron in ionic bond, this is ionic, you will lose electron from the metal, electron will go away, and this will become plus, or plus 2, or plus 3, whatever, and the non-metal, which I'm going to call A, will receive the electron and will become A minus, or A2 minus, or whatever. And then what will happen? They will attract each other as by what? Electrostatic force. Electrostatic. All right? It will be, the bond will be formed by actually attraction. I will take this away. And what will happen? This is plus charge, and this is minus charge. And what will happen to these two? They will what?
Be attracted to each other.
Attract each other to make the bond. If there is another metal here, another ion, and another A, what will happen to them? They will also attract, right?
Yes.
But at the same time, can these attract each other? Yes, they attract each other. All right? And that's why the melting point is what? Very high. While, let's see, for example, nitrogen, and make this, and there is another nitrogen. Can these two molecules attract each other now? There is no charge, no bonding, there is no charge, no bonding, no nothing. That's why there is no attraction between them. And that's why you'll find that the, what's the melting point of nitrogen? Nitrogen gas. Yeah, nitrogen is gas. This is clear. Because there is no attraction at all between these molecules. The attraction between them is so weak or nothing, so that each molecule is independent from the other molecule, and that's why you will find usually the molecular compound or covalent compound have very low melting point. Melting point is very low, -23 for CCl4, while for NaCl, which is salt, it is 101.
I have a question.
Yes.
The attraction between the two molecules of ionic compounds. Is it a ionic compound or a covalent bond?
So
What make them attract to each other?
Charges like magnets. This is minus. This is plus. Are they going to attract each other?
Ah.
Minus and plus. Is this going to attract another one? Yes. If I put another M here, is this going to attract to this one? Yes or no?
Yes, yes.
Of course, everywhere. It can attract it from everywhere. And that's why this is...
so always M will be between two A's.
M will be between A's, yes. And A's will be between M's, yes. Exactly.
Yes.
Okay. And they are usually soluble in water. Not all of them, but most of them. We took in chapter 4 the compounds that are not soluble, but many of them are soluble in water. And usually they conduct electricity when they are liquid or when they are in water. This is a unique compound. But molecular compounds or covalent compounds are very low in solubility of water, and they are usually not soluble or very low solubility. Very low solubility. It does not dissolve in water. And they are very poor or non-conductor. They don't conduct electricity. Is this clear? Good. Now, electronegativity. Electronegativity. And I will tell you now. If we have nitrogen, or even start with hydrogen and hydrogen. Start with hydrogen and hydrogen. Okay. Where are the electrons between this hydrogen and this hydrogen?
In the middle, between.
Exactly in the middle. But when we have hydrogen with helium, how many electrons around hydrogen? 1. Let's put it this one. Hydrogen has 1. Fluorine has how many? What's the valence of, what's the dot symbol for fluorine?
7.
1, 2, 3, 4, 5, 6, 7. How can we make fluorine with 8?
Add 1.
By sharing 1 electron. Now, fluorine is having 8 electrons, which is happy, and hydrogen has 2 electrons that does not need more than 2 electrons. When this bond takes place, we will find that the 2 electrons are in here. Okay, let me make it this way. What am I trying to do here? I want to tell you that the shared electron between fluorine and hydrogen are now closer to fluorine than hydrogen. They are closer to fluorine than hydrogen. So if we take this line, you will find that it's not in the middle exactly. It is closer to fluorine. And we call this electronegativity. Electronegativity. So I want now to define what's electronegativity. I want you to memorize the name, electronegativity. Electronegativity is ability to attract electrons, shared electrons, closer to an atom. So we say in this case, the element that attract electrons closer to it than the other, we call it more electronegative. So let's look at HF. Which one is more electronegative, hydrogen or fluorine?
Fluorine.
Chlorine?
Fluorine.
Chlorine, or I mean fluorine. Fluorine is more electronegative. Why are you saying this? Because the way I draw it. How did I draw the electrons?
Closer
You
to
draw
fluorine.
it like closer to fluorine.
Closer to fluorine. All right. Is this clear? Very good. Now, this electronegativity, which we define it, and I hope don't forget the definition of electronegativity. And I want you to get your periodic table. Look at your periodic table. Look carefully at your periodic table. There was numbers were given to elements to show their electronegativity. And the electronegativity was calculated, and I want you to memorize these numbers that I'm going to write now. The fluorine was the highest, and it was given the letter 4. This is it has a meaning, but we are not going to go into the meaning. I want you to know that the electronegativity of fluorine is 4. Look at your periodic table. What comes before fluorine?
Oxygen.
Oxygen.
It was given electronegativity by 0.5 less than fluorine. What is the electronegativity of oxygen?
3.5.
Exactly. What comes after nitrogen?
A.
Oxygen. Before nitrogen. Before oxygen. right?
Nitrogen. Nitrogen.
Okay, and what before nitrogen?
Carbon.
And what's before carbon?
Boron.
Boron, good. Now, each one is given by 0.5 less. What is it for nitrogen then?
3.
3 point what?
3.0.
Good. What is it for carbon?
2.5.
What is it for B?
2.0.
2.0. I want you to memorize this one. Did you memorize it already?
Yes.
Okay. And then you can derive this easily, right? Right or wrong?
Yes.
Yes, yes. Right.
In addition to this, I want you also to memorize that hydrogen is 2.1 and chlorine is 3.0. I want you to memorize only these numbers, which is these and plus these two. Okay, read it now and memorize them. Did you memorize them? Okay. Was calculated for all the periodic table. And the periodic table, as I said, don't memorize these numbers except which one they are going to memorize. What is it for fluorine? Fluorine, everybody knows. What is it?
4.
4.0.
Oxygen.
3.5.
3.5.
3.5.
3.
3.
0.
Then carbon.
2.5.
2.5.
And then boron.
2.
2.0. Did you memorize these at least?
Yes.
Yes.
Others that I want you to memorize. What is for hydrogen?
2.1.
2.1.
And for chlorine.
3.
3.0.
3.0.
The other, I don't want you to memorize. Don't worry about the rest. But I want you to know generally, as you go down in the periodic table, what happened to the electronegativity?
P lower. P lower.
Decrease.
Descent.
And as you go across from this side to this side,
It increases.
increase.
Like the atomic radius.
Yes.
Ah.
It is increasing this way and this way. That's why,
Ah.
which is the highest?
Fluorine.
Fluorine. And which one you think will become almost the lowest or the lowest?
FR.
FR.
Yes, that's the lowest because it is this side and this side. So it is the lowest and fluorine is the highest. Is this clear? Now, when electrons are shared, like for example, fluorine with fluorine, where are the electrons are going to be? Where are the electrons, the shared electrons?
The middle. The middle.
Exactly in the middle. Why?
Because
Same,
they have the same
electronic.
electronegativity.
Exactly, because they have the same electronegativity. They will share by the same amount. Okay, good. Now, if I have carbon with fluorine or chlorine with fluorine, where the electrons are going to be closer to fluorine?
Fluorine, because it has more or greater electron negativity.
Is it going to be closer to fluorine in case 1 or 2?
2. 1.
Which one is closer to fluorine, case 1 or case 2?
Case 1.
Case 1 is closer. Why?
Because carbon have lower electronegativity from the chlorine.
What's between them? What's the difference between them? What's it for fluorine? Everybody knows fluorine. 4.
1.5 different.
4. And what is it for carbon? 2.5. What's the difference? 1.5. While if it is between fluorine 4 and chlorine. What is it for chlorine?
3.
3.0. The difference is 1, and that's why this one will be further away from fluorine like this. It will be closer in this case to fluorine than this one. So the more the difference, the more it is closer to the higher electronegativity. Is this clear? All right. This type of bond, we are going to have a special name for it. We're going to call it a polar covalent bond. First question, why did we call it covalent?
Because it's sharing.
Sharing.
To non-metal.
It is sharing between non-metal and non-metal. That's why it is covalent. But what's the polar means?
Because one attracts the other.
That their electron negativity is not equal for both.
polar بالعربي.
قطبي.
قطبي. معناته في أقطاب plus and minus, and that's why we call it polar, because the electrons are closer to fluorine. There will be slight charge of negative in fluorine and slight charge of positive in chlorine. And here will be slight negative, and this chlorine will be slight positive. Clear? How about this fluorine and this fluorine? Is there going to be any slight positive or negative? What
No.
will be the charge in this fluorine and fluorine?
No charge.
It will be 0. Clear? Good. Now, let me tell you the other things. Now, we have 3 types of bonds. We have covalent, and we have polar covalent, and we have ionic. All right. We should look at the, and if you notice, the polar covalent is between the ionic and the covalent bond. Between the ionic and the covalent bond. Like, for example, if I draw here Na F, this is definitely ionic bond, right? And what am I going to do about the charge? I'll put plus here and minus here. Why did I do this? Because the electron is lost from sodium and it becomes 100% available for fluorine. And I will draw the 8 electrons around the fluorine. There was 7 and 1 electron come from sodium, and now there is 8 electrons in the fluorine, and there is full charge, minus charge in here. While in covalent bond, I have fluorine, and the electrons are exactly in the middle. Like this. And what will be the charge in each fluorine?
0.
0. Exactly. Clear? Okay. But if I have something like HF, where the electrons are going to be? They are going to be shared. That's why we call them covalent. But they will be what?
Closer to flow.
To fluorine than to hydrogen. And now it is like this. Because they are closer to fluorine than to hydrogen, there will be charge, negative charge on fluorine, and there will be positive charge in carbon. Okay, is this going to be -1? Like this one? This is -1, this is +1, right? Is this going to be +1 or -1? No, it cannot be like this. It will be less than 1. And that's why we write partial negative. It's not 1, it's less than 1. Partial negative. Clear? And the other one will be what? Partial plus. Clear? Polar covalent, because it's in the middle between what? Covalent and ionic bond. Covalent and ionic bond. Is this clear? Any question? Let me ask you a simple question. If the partial covalent fluorine, is it going to be 1?
No, less than 1.
It will be less than 1. It will be definitely less than 1. Why are you saying it is less than 1? Because it is what? Partial. This symbol is for partial. Don't forget this symbol. What's this symbol?
Partial.
Partial means less than 1. Less than 1. Okay, good. Now, let me ask you, let's assume that this partial negative is X. Then what will be the partial positive in hydrogen? If this is -X, what will be the partial in hydrogen? What?
X.
Plus X.
Plus X. Is this clear? Is this clear? And this X.
Greater than 1?
X must be greater, less than 1. Not even equal. It must be less than 1.
So the partial of plus is greater than 1. That's what I mean.
Partial what?
The partial of the positive is greater than 1.
Partial of the positive greater than 1? No, it will be less than 1 also. X is less than +1, -1, and the X for the other one is less than +1.
Okay, I understand now, yes.
Yeah, it is, for example, let's assume that it is maybe 0.4 on fluorine, minus 0.4 on fluorine, then what is it going to be in hydrogen? Let's assume it's 0.4.
0.4.
In high oxide.
Doctor, is X supposed to be bigger than -1?
No, X must be less than 1.
It would be 1 point something, not 0 points.
No, 0 point.
So, doctor, it's greater than -1. -1.
Take the absolute value. I got you. No, it's not -1.1. It is 0.1 or 0.4. Take the absolute value. This one is the charge only. This value must be less than 1, and this is the charge on fluorine, and this is the charge on hydrogen in this case. In this case, if we have HF and I want to draw, this will be minus 0.4 and this will be plus 0.4. So the value, the absolute value is less than 1. And I'll give minus for fluorine and plus for hydrogen. But why did I put minus for fluorine and plus for hydrogen?
Because lose electron, okay?
Or electronegative. Is this clear? Is this clear? I hope so. Okay, now, if the difference, how can we tell if the bond is covalent or polar covalent or ionic? Look at the electronegativity. What's electronegativity? What's electronegativity? Ability what?
To the electron.
To attract the electron stronger than the other atom. If the difference in electronegativity is less than 0.5, then we will consider that this bond is covalent. If it is greater than or equal to 2, then we're going to consider this bond is ionic. And if the difference between them, between these two, between this number 0.5 and 2.0, then it will be polar covalent. Okay. If just a second, is this polar covalent or covalent or ionic? Yes.
Covalent.
Covalent. Why? Because the difference between them is what?
0.
0. 4 minus 4 is equal to 0. And that's why this is covalent. Okay, let's try something else. Let's try hydrogen and fluorine. Is this bond covalent or polar covalent or ionic? Take the difference. What's it for hydrogen, for fluorine? What's it?
And for hydrogen is 2.1.
2.1. Don't forget this. What's the difference?
1.9.
9.
Is this covalent? No. Why?
Because it's greater than 0.5.
Is this ionic?
No, less than
No.
Less than.
Because
2.0.
Okay.
Less than.
So it is what?
it's polar covalent.
Very good. Let's try something else. Let's try instead of HF. Let's try HC bond. What is it for C?
3.
No. Is it 3? No. (2.5) and hydrogen 2.1. What's the difference?
0.4.
2.4. Is this ionic bond?
No, it's covalent.
Is it polar covalent?
Covalent.
It is only covalent. It is only covalent. Good. Very good. Let's solve this problem. What is the bond CLF?
3 and 4.
Exactly. So is it covalent or covalent or ionic?
Polar covalent.
The Cl and F, what's the difference? What is it for fluorine? 4.0. What is for chlorine?
3.0.
What's the difference?
1.
One.
Polar covalent. Okay?
Polar.
Polar covalent. Now, I don't want you to memorize this, but it is given to you here. CS and bromine. CS is 0.7 and bromine is 2.8. What type of bond is this?
2.1. It is ionic.
Ionic. Fantastic. Last one. C4, C2H4. Anything with carbon and hydrogen is what? Carbon and hydrogen.
It's covalent.
Why?
It's less than 5. 0.5.
Difference is 0.4. Is this clear? As I said, they got these numbers from the table. I don't want you to memorize this table. I want you to memorize the one with the red lines only. The one with red you must memorize. And it's very easy to memorize if you know that this is 4 for fluorine and this is 3.5, 3.0, 2.5, 2.0. I already memorized them. This one is
So, Doctor,
and this one is 2.1. The rest don't memorize.
Doctor, the numbers will be given. So,
Yes. No. For this, maybe I will not give it to you. For the one I told you to memorize. But usually I will give it.
But I mean, how can we calculate without the numbers?
As I said, if I want to give you CS, I will give you CS. But maybe I'll tell you the bond CS if the electronegativity of CS is 0.7. Is this polar bond or ionic? I did not tell you. Sorry, I told you only CS.
Already know.
You want
Polar.
Or flow. We said it's
No, polar, sorry, polar.
very good.
Ion.
Now, when we have polar bond, we draw it this way. We put an arrow, look at the arrow here, arrow like this, toward what? To the partial negative. And we put like a plus on the partial positive. That's how we draw polar bond. And as I told you, we put partial positive on this one and partial positive in this one. This one, this arrow here is force. It's type of force. This force is called dipole.
Be honest.
What?
Today class is great.
Dipole moment. I want you to know this point. Okay, what's this? This arrow, what is it? It's kind of forces. You know forces? Any force. It is force. What's the name of this force? You have to remember the name.
Dipole moment.
Dipole moment. Dipole, I repeat it one more time. Write it and memorize it. Dipole moment. And we represent it by a U like this. This is called dipole moment and we represent it by this letter. And the unit that we use for the dipole moment is called dBi, capital D, which is called dBi. You don't have to memorize the name. I mean, memorize the name, but you don't have to know even. I don't know what's the spelling, but I'll find it for you. It is dBi, and we do it by capital D. When we calculate the force, it's called dBi. What's this letter? What's the name of this letter? What's this letter?
U.
Yeah, what is it?
New.
Dipole
moment.
What do you mean by the dipole moment?
The arrow.
Is this arrow for this force? Okay, what's this letter D?
Unit of dipole
The
moment.
unit that we use for the dipole moment, and it is called dBi. dBi. Clear? Very good. This U, what's this now? What's this letter?
Dipole moment.
Dipole moment. And R,
Yes, maybe.
what's R? Distance. All right. And what's Q? Q is the charge on the ionic bond. Like for example, when I told you when we have the one I gave you, let's assume that for HF, and I told you maybe if this is minus 0.4 and this is plus 0.4. The Q is this charge. Should we put plus 0.4 or minus 0.4?
For which? For fluorine?
Q. It doesn't matter. All right? It is force, so we will take the absolute value, which is in this case, if we have these numbers, of course, maybe these numbers are not correct. But this dipole moment is 0.4, and you can calculate the force. Clear? Okay. Now, this 0.4 is the charge of the electron. The charge of the electrons. This is the charge of one electron. And the charge of the electron, okay, now I want to tell you that the charge of one electron is equal to 1.60, 1.6022 times 10 to the power minus 19 Coulomb. And the debye is equal to this number, coulombs times meter. Now, what's the unit of U? What's the unit for U?
Coulomb per meter.
Debye. The unit for U is debye. What's the unit for Q?
Coulomb.
Yes, we use C, which is what? Coulomb, not charge. We will change charge into Coulomb. Okay, and then what's the distance for, what's the unit for R?
Meter.
Meter. So the debye is the unit of Coulomb to meter. Is this clear? Don't forget this law now. Don't forget this law. Write it, because we'll solve a problem right now. Okay, good. Now, the debye, which is U, was calculated. Dipole moment, which is U, was calculated for atoms, and the bond length, which is R, was also calculated in angstrom. What's angstrom?
One multiplied 10 to the power minus 10.
Exactly. Don't forget this also. Okay, now let's talk about, now we have, this is the dipole moment for HF. I want to solve a problem now. I want you to calculate Q for HF. Okay, don't forget that. U equal to what? Yes?
U
Q,
multiplied by
Q
R.
multiplied by R. Okay, now what's U in this case? It is 1.82. Write this, because I will give you another slide in a while. And what is R? What is R?
0.92.
Angstrom. I want you to calculate Q. How are you going to calculate Q?
We need
Then,
to
this to meter. And then change this to Coulomb meter. Okay, how can you change this to meter? 0.92 times 10 to the power minus 10 meter. Good? Now, 1.82 debye. I should multiply it by, I'll give you now this slide. All right, This is how to change the pi into Coulomb meter. All right. So take this number, which is copy this number and give it to me now. 3.336 times 10 to the power. What was it? 1.82. Was it 1.82?
Yes.
Okay. 1.82 divide, change it to Coulomb meter.
Multiply by 3.336.
3
Multiply 10 to the power minus 30.
minus 30 Coulomb meter divide by
1.
divide. I will
Okay,
go and you have the answer. Give the answer quickly in your calculator.
Doctor, do we have to memorize this?
No, these numbers don't memorize them. I will give it to you. All these things. Clear? Now, yes. Did you calculate Q?
Yes.
This is
1.
the distance was 0.92 times 10 to the power minus 10 meter. Calculate what is Q.
It is 6.59 multiply 10 to the power minus 20.
59.
Yes. Multiply 10 to the power minus 20.
Minus 20. Very good. Who got the same answer? 6.59 times 10 to the power minus 20. What's the unit?
Meter.
No.
Column.
Yes.
Coulomb.
Column.
Coulomb. Can you change it now to electrons?
Yes.
Yes.
Divide by 1.6022 multiply 10 to the power minus 19.
Go ahead. Then what will be the charge in electron charge? Yes. Yes. Hello?
Zero point 411.
Who got the same answer?
Yes, 0.4.
Yeah, I guess it.
Now I can throw this and write what's the charges. You remember when we write an ACL or an AF, how do we write it? We write minus here, minus 1, and here plus 1. Complete, it's ionic. But this one, we can write here minus 0.411, and this one will be what?
Plus 0.41.
Plus 0.
Do you know how to do it now? So, what's the percentage ionicity of HF? What's the percentage ionicity? What's the percentage of the ionicity? If it's 100% ionic, it will be 1. But it is only 0.411 divided by 1 times 100. So what is it? 41%.
41.1%
ionic. 40%, 41.1 ionic. And how much covalent? 59%.
58.9.
58 or 59% covalent. Is this clear? I hope so. Good. And with this, we can do things. Now, we draw Lewis structure for last time for many compounds. Can we draw the Lewis structure for CS2? The way you have to draw it, count how many electrons do we have for carbon. How many electrons do we have in carbon?
4.
4. How many in sulfur?
6.
6 times 2, because we have, see, we want to draw it for CS2. What is it now? That's the total.
16.
16. You should put 16 means how many pairs is this? Okay, we have what? 16 electrons. This means how many pairs?
8 pairs.
8 pairs. Why did I divide by 2? Because the pair consists of what? 2 pairs. Then distribute the 8 pairs. This is the carbon. This is S. And this is S. I used already, how many pairs did I use?
2.
8 pairs.
2 pairs.
Oh.
2. If I use 3, 4, 5, 6, 7, 8. Is this acceptable?
Yes.
No. Why it's not acceptable?
Because we need
How many electrons around the sulfur? 8. How
Yes.
many around the sulfur?
8.
But how many around the carbon?
4.
So I should take one of these pairs and put it between the carbon and sulfur. Now, how many pairs are around this sulfur? Sulfur 1, we call it. How many pairs?
8.
8.
8.
How many pairs around this sulfur? Sulfur
8.
2. 8. And how about the carbon?
6.
Only 6.
6.
That's not acceptable. What should I do? I can take 2 pairs of this one pair and put it here. Now, is this acceptable?
Yes.
Yes. Acceptable. All right. And that's it. Now, let's do it for last example. For example, if I take NO2 minus, then how many around the nitrogen? How about oxygen?
12.
12, because we have 2 oxygen. And we have also the minus charge, we add 1 electron, plus 1. What's the total number of electrons?
18.
18, is it? Yeah, 17, 18. All right, now I put the nitrogen, at least one pair here. Oh, sorry, 18, how many pairs is this?
9.
9 pairs. I already used how many pairs?
2.
2, 3, 4, 5, 6, 7, 8, 9. Is this acceptable? Is this acceptable? No. Why not?
Doctor, I can't see
شوف الشاشة يا دكتور.
the pairs.
الشاشة قفلت.
قفلت الشاشة ليش؟
ما عشان انت هذا.
You stop sharing.
No, still.
رجعوا كرت.
يس الحين تمام يا دكتور.
الحين تمام. طيب.
الحين واضح.
As I said, last thing is I will take this pair and put it here. Now everything is 8. That's the Lewis structure. You have to know how to draw the Lewis structure in a very nice way. Okay, with this I will stop here. All right, and as usual, we'll go to the attendance. And let's see. Okay, so now I'll open the thing for you. You already have it in attendance in your Blackboard. Go ahead and find it. You have it.
Doctor, can you send it?
It is sent for you now. Okay, you have 1 minute to take the attendance. Go ahead. وخلاص انتهت المحاضرة إن شاء الله. See you next lecture which is Wednesday إن شاء الله.
دكتور
hour الله يحييك.
It's still recording.
يا دكتور
دكتور
Yes.
8.0